Okay, same idea. Probably is either inconsistent or dependent, but let's do the work. I think eliminating x is going to be my best bet, because if I just take that first equation, multiply it by 2, it's going to straight cancel with equations 2 and 3. All right, so 2 times x plus y minus 2z equals 0. That'll give 2x plus 2y minus 4z equals 0. So that's my modified equation 1. So let's combine that with equation 2, negative 2x minus 5y plus 3z equals 0. Here's my modified equation 1. And I get 0x, negative 3y minus z equals 0. All right, now I'm going to take this equation and combine it with 3. Negative 2x minus 2y plus 4z equals 4. Okay, when I do this, and probably should have done this first, here's what happens. I get 0x, 0y, 0z equals 4. Okay, that is not true, so that means this is an inconsistent system. There's no solution. It turns out these are parallel planes. Okay. This one isn't too bad, really. All you have to do to start this one is to clear the fractions. And then you just do it like the others. So, common denominator for all of these is going to be 8. Common denominator for the second one is also 8, and it looks like 6 is the common denominator for the third one. So, multiplying everything by 8, negative 1/2 times 8 gives me negative 4x. 7/8 times 8 gives me 7y. And negative 1/2 times 8 gives me a negative 4z. And 3 times 8 is 24. This is probably where the most errors happen, just forgetting to multiply the constant. So there's my new improved equation 1. Let's see what equation 2 looks like. 1/8 times 8 is 1x. Same with the y. And 3/4 times 8, 4 goes into 8 twice. 2 times 3 is, and don't forget the negative 6z. And 2 goes into 8 4 times. 4 times 3 is 12. So there's my second equation. And I get negative x. 3 goes into 6 twice, so plus 2y, and minus 6z equals 12. All right, well, equation 3 and equation 2 will definitely they'll cancel out the x's, and then I could probably use equation 2 to cancel out the x's with equation 1. So let's start with just 2 and 3. And we get 3y minus 12z equals 24. That's my first equation in 2 variables. Now I'm going to take equation 2 and I'm going to multiply it by 4 to get a positive 4x. X plus y minus 6z equals 12. So my modified equation 2 gives me 4x plus 4y minus 4 times 6 is 24. And 4 times 12 is 48. I got to tell you that the, so I'm going to call this equation B. The minor errors are killer in this. I've had to redo several of these when I get to the final answer and it's not correct. All right, so now I'm going to, wait, I have not started explaining stuff. Try that again. lost track of what I was doing. Funny, that led to an error as I was talking about errors. Okay, 4x, 4y, and now I'm going to combine this with 1 part I didn't do. All right, numbers are getting kind of big. Don't be too alarmed. 4, 5, 6, 72. Okay, so 11y, I started 72. You know what? There's no nice elimination here. So I am going to take equation B, and I'm going to multiply it by a -3. And then I'm going to take equation A, and I'm going to multiply it by a positive 11. That will allow me to eliminate the y's. I could either do that or multiply by 12 and 28 or try to find a common denominator. Yeah, this will probably be a little more straightforward. Okay, -33y. 28 times 3 is 75 plus 6. 81z. And 72 times 3, oh, these numbers got really big. 216. And let me take another look at that. 28 times 3. Actually, that's going to be an 84, not an 81. Okay. Doing my multiplication over here, I get 33y minus 132z equals 24 times 11 is going to be 264. Okay, I'm going to stack these on top of each other and eliminate the y's. 33y. I'm going to stop the video and see where my error is. All right, well, I have a sign error. When I multiply by -3, I only multiply the first term by the negative. That means the 84 is positive and the 216 is negative. All right. So, y's cancel, and when I combine 132 and 84, I get a -48z. And 264 minus 216 is also 48. So it looks like z is equal to -1. Okay, working backwards, I'm going to go find one of those equations that has y and z in it. And looks like equation A is a little bit smaller. Okay, so 3y minus 12z equals 24. All right, so we get 3y plus 12 equals 24. Y equals 12, or y equals 4. Okay, I have a y and a z. Let's look back at my first 3 original equations. Oh no, not the original. We're going to look at the ones that we cleared the fractions, hoping we did that correctly. I'm going to grab the modified 2 equation, x plus y minus 6z equals 12. Y is 4, and z is -1. X plus 4 plus 6 equals 12. X plus 10 equals 12. Subtract 10, it looks like x equals 2. And there's our 3 answers. Again, this one went long.